Wait a minute. Okay, one is a time space, time switching, and also one more important configuration is the space time space switching. Okay, dear students, this one the presentation is visible.
No, sir.
Okay. Now it is visible now. Okay.
Yes, sir.
Okay. See, in the last class, we are discussing about the some of the space and time switching configurations. Okay, in the space time space, each of incoming PCM highways and to be connected to the key links by cross point of A, and also another end also we should connect the M outgoing PCM highway by cross point of C. Okay, in that particular configurations. Okay, each link containing a time switches, and to make this connection between the time slot of X of incoming highway and time slot of Y of an outgoing highway, you should select the necessary address from the X free speech store and Y free in its connection store. Okay, the time switch is then set produce a shift from X to Y, and this connection is completed by operating the appropriate switches. Okay, uh, in the C. Okay, that is the working explanation of the space time space switching. And one more thing is the time space time switching. Same thing here also. Okay, we are using the two time switches, and in between we are using the space switches. Okay, how to make the cross point between this M incoming and M outgoing highway through these space switches only. Okay, same thing here also. There are M incoming and M outgoing PCM highways. This should be connected to the time switches, and then the incoming and outgoing time switches are connected by the space switches. That is the M into N crosses. That will be represented by B switches. Okay, they make the connection between these two incoming M incoming and M outgoing highways means they will take the different time plots of. So I'm taking the example of the assuming the some different time slots. Okay, for suppose I'm considering X time slots for incoming highways and Y time slots and outgoing highways, then we should necessarily choose another time slot that will be represented by X, which is free in the connection store, and a connection store of the incoming highway, and the speed store in the outgoing highway, and then connection will be established by setting the timer switch to shift to X to Z, setting going to okay for the incoming connections, and then outgoing time switches from shift from Z to Y, and operating appropriate cross point. Okay, at the time Z in each frame. Okay, through this we can make the connection we exhibit between the M incoming and M outgoing PCM highways in the space switches. Okay, till up to we are discussing the previous class. Again, one more important topic discussed in the previous class is the bidirectional paths. Okay, in earlier 4-wire systems, we are considering we need some 2 wires for the transmission, 2 wires for the receiving the informations. To overcome that one, instead of using those 2 wires only, we can can get receive the we can receive and transmit the information in a in a single wire in a 2 wires only. Okay, we can eliminating the number of ways in this bidirectional path technologies. Okay, here in the bidirectional path, the switching network sometimes they taken space time space switching or time space time switching. Okay, these are the these switching are the unidirectional transmissions. Okay, that's why since PCM transmission system use a 4-wire circuits, and also it is necessary to provide the separate path for the sending and the receiving the channel. Okay, and one way is provide the separate switching network for each direction of transmissions. Okay, this can be avoided by connecting the sending highways for both incoming and outgoing circuits to one side of the switches. Similarly, in the receive side also, there is a same thing, the same again they will avoiding the extra connection for the both incoming and outgoing PCM in the receiver side also. And also in the previous class, I show the diagram of the unilateral. Okay, there's a you can see. Okay, this is your bidirectional pathway. Okay, this also we discussed in the previous class. Okay, after that, one more thing, important thing we have discussed. Just we have given the previous class, just I am given the brief introduction about the synchronization. Synchronization means nothing but, see, we have different types of call processing will be there. Okay, intra or inter or incoming or outgoing call. Okay, for outgoing, otherwise some intra, the customer will be outside the particular local exchange. It means that, suppose the customer A will be the, in the particular telephone exchange, and customer B will be the another telephone exchanges. Means we have to make these connections. How to synchronize between these two customers before connecting the uh, system. Okay, there is a two different types of mechanisms are used. Okay, it may be unilateral or it may be bilaterals, and then in this unilateral bilateral configuration, again we have a different classification. Means different types. It may be a master and slave configuration, or it may be a mutual exchange, mutual independence. They will synchronizing the clock frequencies. Okay, in that, the first one is that, in the synchronizing link, maybe a unilateral and a bilateral. Unilateral means one side, bilateral means both the exchanges can mutually we can adjust the frequencies. Okay, in the first case, there is a master and slave relationship, and then the clock frequency of the exchange at one end of the link is controlled by the slave by the exchange at the other end. And in the second case, there is a mutual relationship. Okay, each exchange influence the frequency of other. Okay, till up to this, we can discuss in the previous class. Now we are on to the exact, what do you mean by synchronization, what do you mean by the unilateral synchronization. Now we discussed today. Okay, dear students. See, in this, the first case, what is that? Unilateral synchronous system. That is the master slave relationship. Suppose you can consider the exchange A is the master and exchange B is the slave. Okay. Dear student, presentation is visible. Presentation is visible. Yes or no?
No, sir.
Okay, wait a minute. Um, it is now. It is visible, dear students. Dear student, now it is visible. Say yes or no. Hello, dear students.
No, sir.
Okay, wait a minute. Now it is visible. Dear student, now it is visible.
Yes.
See, now it is visible now. See, the exchange A is the master and the exchange B is the slave. Okay, see, dear student, please note on this diagram. This is a block diagram. Okay, see, in the unilateral synchronous system, the exchange A is the master and the exchange B is the slave. See, exchange B is determine the phase difference between its own clock and that of the exchange A by fill the align buffer on the incoming link. It means that there is some there's a phase difference, nothing but there's a differences will be there. Okay, there's some frequency variation will be there. Okay, that frequency variation will be done by the exchange by filling the align buffer on the incoming links. Okay, I'm giving in the previous class also I'm giving the example. Okay, what are the example I'm given? I'm giving the example for motors. Okay, see that during the no load condition the motor will be rotated at the synchronous speed only. Synchronous speed means the rated speed. Okay, if you're putting some load on the motor means automatically what happens, the speed will be gradually decreases one little bit, 5 to 10% will be decreases. Okay, okay, what is that variation is called as a slip. That is variation between these two load and no unload, load and no load condition is a slip. Okay, some slip differences will be there. Here also same thing, because the exchange will be operated with a separate clock frequency, and the exchange will be operating with a separate clock frequency. Okay, how to synchronizing these means through this master and slave relationship. Okay, here we can observe that we can assume that the exchange A is the master and the exchange B is the slaves only. Okay, in the exchange B determines the what is the phase difference. Phase difference, what much of variation will be there, frequency variation that will be determined by the exchange B. Okay, and that of the exchange way by filling the align buffer on the incoming link. Okay, and then a changes in space causes a step increase or decrease the clock frequency lasting for few millisecond. Okay, there is, we can see there there is a clock frequency will be there in the exchange. Through this we can increase or decrease the frequency. Okay, if you are match it the frequency, suppose the frequency will be lower than customer B, exchange B means we should increase. Okay, suppose the higher means it is decrease. Okay, both will be same means it will be doesn't changes. Okay, that's why it may be a step change, it may be a step increase or step decrease in the clock frequency for last of few milliseconds. Okay, there's a one type of the synchronizing system. Okay, and another type, uh, see, this for unilateral. Okay, this synchronization is the, there is a synchronization link will be there now. There's a unilateral. Now same thing, the master slave relationship. We can say observe the figure. This is a master, a slave. Okay, same thing, a single-ended bilateral synchronization links. You can see the above figure. Okay, the decision process is made at each of the link. As a result, the both the exchange clock achieve the same average frequency. Same average frequency. The exchange would be mutually agree of common frequency without being controlled an overall master clock. Okay. See, we can see observe this is a figure for the mutual relationship. Okay. Initially I told there's a two cases will be there. One is the master and slave, and another one is the mutual relationship. Okay, in the second figure what we are seeing that there is a mutual relationship. Okay, this is also a single ended bilateral synchronous link, and decision process is made at each end of the link. As a result, both exchange clock achieve the same average frequency. The exchange would be mutually agree a common frequency with being controlled by overall master clock. Okay, and what is the disadvantages for the single-ended unilateral network? A disadvantage of single-ended unilateral and bilateral synchronous system is that they are using the phase compensator are unable to distinguish between the phase. There is a phase difference or phase section due to the frequency drift, and those due to its change in propagation time. Okay, there is a disadvantage. One more is that to overcome this, they will go move on for the double-ended. Okay, there's a double-ended system, and then this can be eliminated the influence of the propagation delay by subtracting the change in phase determined by the end of each link from that determined of the other end. Okay, then we should go for the next important what is that, to overcome this kind of disadvantages we are move on to the double-ended system. Okay, double-ended synchronizing system. See, this is a circuit diagram for your double-ended circuits. Okay, it is visible now, double-ended. Okay. Now, see, everyone should take down this double-ended unilateral and bilateral. The first one is the unilateral, second one is the bilateral. Okay. See, similarly, you can see the figure. There's a bilateral. It's a, for the first figure is the representing the single-ended bilateral synchronous link. Okay, and then the in this case, the decision. Okay, the process is made for each of end of the link only. As a result, the both the clock exchange achieve the same average frequency. Okay, in a mix of such synchronizing node, the exchange would be mutually agree for a common frequency without being controlled by overall master clock. Okay, then we are discussing the what are the disadvantages in the previous cases. One is the then we need some phase compensator. Okay, and then these phase comparators are unable to find out the what is the exact phase difference between the two local exchanges, and also it takes some delay also. And one more the disadvantages for the single-ended unilateral and bilateral asynchronous system is uh, to overcome this, we can go for the double-ended system. Okay, in the first case, same as it is. Here also in the double-ended unilateral double-ended systems, again there is a master-slave as well as a mutual relationship. Okay, and then here they by using this kind of double-ended system, in this case, in this system, we can eliminating the delay. There's a propagation delay. Okay, by variation by subtracting the change of phase difference. Okay, that will be that will be determined at the end of the each link. Okay, clear? And then there is a phase error detector at each exchanges. You can see there is a box is there now. There's a square box will be there now. That is called as a phase error detector uh, at exchange A and at exchange B. Okay, in the both the exchanges we have including the one more component. There's a phase error detected. Okay, here the phase error detector will be detected by the exchange A. Okay, be in the phase changes due to the uh, difference between the each clock of the uh, exchanges. Okay, and then the phase can be detected by the exchange B. The difference between the two measures are eliminated. Okay, like that, a single channel is required to carry the result for result of phase comparison in another end of the link in order to make subtraction. Okay, similarly, similarly also, in case of unilateral network, this channel was needed to in only one directions. For a bilateral network, again a signaling channel is needed in each directions. Okay, you can see in the figure also. In figure, the last figure. Okay, again asynchronous network for an integrated digital network. Since this is an auxiliary network, must link all the exchanges in a IDI. Okay, then synchronous network has some nodes and the same hierarchy structure as the parent public telephone exchange. That's the PSTN. The synchronous links are provided by the PCM system that carry a normal traffic between the exchanges. Okay, there is a thing. Okay, now what happened in advanced DSS system? They are using the integrated digital networking. Okay, suppose in the synchronous network for this kind of IDN, there's integrated digital networking. Okay, they require some auxiliary network. Okay, that should be must link to all the exchange in the digital network. There is integrated digital network, and the synchronous network has same nodes and the same hierarchy. Okay, a structure as a PSTN. This is a parent public or public telephone public switch telephone network, and the synchronous links are provided by the PCM system that carries the normal traffic exchange between the uh, two telephones. Okay, okay, this is very simple topic uh, for synchronization. Okay, Then after that, it is audible. It is audible, yes or no? Hello, hello. It is
Sir,
audible.
your voice is breaking, sir.
Now it is audible, no?
Yes, sir.
Then after that, the
Slide is not
next
visible.
important topic. Okay, let's take it. In the next part of this, again, this model, we are discussing about the software system. Okay, in that, what is the introduction? Okay, what are the types of software used, and what are the basic software architecture and software architecture for different levels? Okay, it means that we have different levels. Okay, we have three levels, three-level control. Okay, each level will get. Okay, and also we should study the what is the exact architecture of the level 1 to 3 control. Again, classifications. The software classification with the and car models and software linkage with the car. And some of the future flow diagram, future interaction. It means future interaction is nothing but to say in present we have enough special features are available in our smartphone. Okay, in earlier days, some forwarding, car forwarding, car flow blocking. Okay, these are the features are given in the early decades. Okay, this also we are discussing in this. Okay, first before going to that, we are discussing about the uh, what is the introduction about the okay, what type of software architecture used in modern cases. See, the modern digital classification system is quite complex because of this. We are introducing a number of features in the particular local actions is nothing but the complexity of working of the instances. Okay, this one the presentation is visible.
Yes, sir. Now it's visible.
Now it is visible. Okay, fine. See, in the modern digital system, there's a complexity is quite high because of we are adding some n number of facilities to the system. Okay, then the growth of the growth in the field of software, the complexity of the DSS also will be goes on. It means that by adding some features, means we should also design the software. We should also software system to implementing that particular services. Okay, then there is a the adding n number of special features to the particular network means the software, the growth of the speed of increases and then complexity of the DSS. Okay, and in these chapters, expose the what is the working of the software that drives the digital switching system. Okay, in everything, in everywhere we are using the softwares only. Because in modern digital system we are using the stored control. program systems. It means that everywhere for particular specific some tasks, we need some program. Okay, that's a program. So to do this program, it has suitable software. That's why this chapter will be exposed the working of the software that drives the teacher teaching system. Okay, and then what is the scope of this software? Okay, the first one is the we should now understood about the what is the software architecture of the typical or standard research system, and then we also study the classification of various types of software, and also we describe the call models, and then also we discuss and also study the software linkages that are required during the basic class. Okay. What are type of softwares are used for basic call features? You can take an example for call forwarding, or you take an example of the conference call, take an example for blocking. Okay, for everywhere we are using every features we are adding some softwares. Okay, that's why the complexity goes and increases in the modern DSS. And then the basics of the architectures in the modern digital switching systems actually employs the quasi-distributed hardware software architecture. Quasi-distributed hardware software architecture are used in the modern digital switching system. And then the software employed in the modern digital system at different levels of controls. Okay, we have different level of softwares are used because based on the operations, based on this specific task, we are updating the software. We are updating the proper software, and then the basic software architectures of typical digital switching systems have different types of control softwares are used. Okay, and this level of controls. Okay, how to distinguish the type of the control is depend upon the control and the control of the system. Okay, suppose the low control is the level 1 means it is nothing but it's a low control. Suppose this is a level 3 is nothing but it is a high control. Okay, because the performing that though it means that the low in the low controls they are having some minimum software requirement because only few components are interacted with that particular interface with this particular level of controls. Okay, so take an example for the low level control. Line models, the tug models are interfaces in the particular controlling. Wait a minute. Hello, sorry for the disturbance. See, It is audible now. This one, it is audible.
Yes, sir.
Okay.
Yes, sir.
Sorry for the disturbance. See, in this case, what happened? In the modern DSS, we have different types of software are used in the system. Okay. Actually, generally, we are employing the quasi-distributed hardware and software architecture. Okay. And this software employed in the modern DSS system are different level of controls. Okay. Then see, I'll show the figure. See, it is visible now. The basics of the architecture. Level 1, level 2, level 3.
Yes, sir.
Visible now. Okay, thank you. See, uh, the figure shows that we have different because I'm giving an example here. You can see the figure. The all the level line modes and trend modes are connected to the level 1 control, and all the NCPs are NCP NCP network control system we can control level 2, and network control system we can connect to level 3. Okay. That's why each level having a different software are available. Okay. Here both high level and low level details are necessary to design the switching systems. Okay. Coming to the operating system, like the modern DSS system as an operating system is a part of the software architecture. And an operating system may be defined as the software that manages the resources of the computer or control the task other program. Okay, there's a general description of the operating system. Okay, clear? In the modern digital switching system, it consists for everything, for each level of control, so we are using some separate operating system. Okay. Okay, as a part of the software architecture, the operating system may be defined as the software that manage the resource of the computer system or control the task other program. Okay, that's why we need some software. If specifically some task means we need some software, some control algorithm. So that thing will be controlled by the operating system. Operating system nothing but it's a processor. Okay, and these programs are called as a control programs. Okay, we need to specify some control. They can tell the each model is nothing but that's called a control program. Some supervisory programs and some monitor programs also will be there. Okay, the program may be okay. Different programs will be there. Okay, it may be a control program. It may be supervisory. It can be monitoring program. Okay, is a part of the software architecture. And then we have different types of the operating system are used in the modern DSS. Okay, one is the serial batch system, multi-program system, time sharing system, and real-time system. Okay, this one, please note on this. Okay, see, listen here. This is a basic. This is very important topic. Okay, you should know. You should know this control technology. Uh, Wait a minute. Uh, Listen here. Actually, in the operating system, I already told you people. Actually, this different as a software that manages the resources of the software system or control the tasks, other systems. And then we have different types of programs are used in the modern DSS, like control program, supervisor program, and monitor program. Okay. Okay, these are the some of the main part of this software architecture. And there are some different types of the operating system are used in this modern DSS. The first one is the real-based system, multi-program system, time-sharing system, and then real-time system. Okay. Then operating system is employed by the DSS or real-time operating system because the modern DSS will demand of the demand for the task for the execution in the real time. Okay, suppose you take an example. If you want to activate the particular functions or features within a fraction of second, it back means it is a real time only. Real time activations. Okay, that's nothing but it's a real time activation. Okay, it means we can activate and deactivate the particular features within a fraction of second in the real time only. Okay, that's when the most of the DSS software will be operated in the real time only. Okay, most of that one. Okay, if you want to make the connection between the two systems, how to this connection, these two connections in the real time only. Correct? No? The message sending the mail. That is not a real time. Okay, this almost the DSS will be employed a real time operating system. Okay, that should be perform a specific task to execute in real time. And then typically the real time operating system DSS contact the different layer of the application required to support the telephone feature and then functions. Okay, it means if you want to take an example for the how to call and we get connected between the two users, so initially the testing will be done. Okay, after testing, they said initially we will do the authentication verification. How to do the authentication? Is the subscription is valid or invalid? How to identify? That's why they're using some suitable software to authenticate the particular subscriber. After that, they'll check the testing the line, both the line. Okay, after that, testing the line. After that, again, send the alerts. Okay, and then sending the alerting signal for the uh, card customers. Okay, it means each steps we are using the a different real-time operating real-time software to do that or to execute the particular task. Okay, in a real time. That's why typically the real-time operating system of DSL integrate the different layer of the application. And these things will be equal to support the function. And most modern DHS are quasi-distributed architecture. The processor, the controller for each of the subsystem will be used different OS. Okay, I am showing the figure also. Okay, each systems, each level of controls, they are using the different operating system. Okay, because the each level of controls they are connected to the different subsystems. Okay, based on the performance test, they use the proper software program. Okay, and then see, and then see, there's the operating system. You can see level 1, level 2, level 3. They're using the different operating systems. Okay, suppose there's a kernel. You can see observe in the figure also there is a kernel is there. Kernel also is the one of the operating system. And considering these function, okay, it is considered as an operating system. Okay, they are primitive to the system environment, and it is usually considered the following functions. Okay, what is the main function of this kernel operating system? Okay, that's the first function will be the process control and process scheduling, and second is the memory management, and third one is the input and output controls. Okay, and then the fourth one is the production of memory read and write operations. Okay, see the kernel also is the operating system. Okay, don't confuse that. Each level of controls are using the different operating systems. Okay, what is the function of this operating system is to process the control and process the schedule, correct? And also should memory management this operating system. And input and output controls, whether we request from the terminals for first. Also, it is a memory system. Most of the real-time operating system. The controls that we most of the DSS will be access the kernels. That is the main memory. The highest priority is given to the system. Maintenance interrupt followed by the other types of interrupts required for the call processing and the other ancillary functions. And then the next, you can see the next important course in terms that is the DBM. Okay, it's a database management. Okay, actually, this database are entered in the modern DSS usually for relation and some time distributed. Relation is nothing but in which sometimes it is distributed also. Okay, distributed database implies system database request the data information. The relational database system are used for relation data model in which the relation between the files are represented by the data values in file structures. Okay, there's a two types of the database management will be there in the modern DSS. Okay, sometimes will be distributed. Distributed means the data will be the data will be distributed to the other database controls or maybe individual. Okay, that is called the relations. Relation database system is the relation data model in which the relationship between the files and the related uh, files are represented by the data values in the file records. Okay, the record is relational database is flat. Okay, simply two-dimensional arrangement of data elements. The first one is the grouping of related data items. It's sometimes referred as a tuple. Okay, a tuple is consisting of two values. Two values is called as a pair. A tuple containing many values is called as n tuples. Okay, tuple is nothing but there is a grouping of the grouping of the related data. Related. Suppose you can see example there is a customer is the customer related data that is called as a relationship relational data. Okay, that will be referred as a tuple. Suppose this tuple which contains the two values called as a pairs. Suppose the n values is there is n tuples. Okay, a tuple containing n values is called as a n tuple. Okay. There's an example for this example of this database. One more example is suppose we taken for relation database in case of the DSS database, which is throws the reference of all the directory names that are assigned to the line equipments of subscribers. When the subscriber is goes to output, the scanning the equipment, identifying the line equipment. Database is search for finding the particular directory number that identify the other characters of the lines. Okay, suppose if you go for making a call for other people means actually what identification. Okay, is that a valid customer or an invalid customer? They will check through this database, this relationship database. Okay, this is a customer data. The relation database is a customer data. They will check the okay, he is valid and for cars. Okay, that's why the database management will be two types. One is the relations and then another is the distributed. Okay. And then one more next is the you can see next is the kernel is over, operating system over, then DNS is over. The next important will uh, concept of generic program. Okay, generic program. See, the generic program contains all the program necessary for switching system to functions. Okay, it consists of operating system, common switching softwares, and system maintenance softwares, and configuration management of center office. And also the translation of the data between the customer premises and CO is provided by the telecom. Generic means there's a control programs, also tech programs. Okay, these programs they do some different functions. Suppose you can consider the operating system. Okay, then I will set up generic programs. Okay, again common switching software. Okay, there are also control programs, for maintenance also. Yes, system maintenance. And for management, there's a different management software program. Those are called referred as a generic program. Okay, generic programs contains all the program necessary for the switching system to do the particular functions. So it's called a generic program. Okay, dear students, today I'll stop here. Okay.
Thank you, sir.
ಓ ಇವ್ರು ನಾನು ಅವಾಗಿಂದ ಪಾಠ ಮಾಡ್ತೇನೆ, ಕೇಳ್ತಾ ಇಲ್ವಾ ನಿಮ್ಗೆ? ಹಲೋ,
ಕೇಳಿಸ್ತಿದೆ ಸರ್.
ಕೇಳಿಸ್ತಾ ಇದೆಯಾ?
ಎಸ್ ಸರ್. ಮಿಡಿಲ್ ಅಲ್ಲಿ ನಿಮ್ ವಾಯ್ಸ್ ಬ್ರೇಕ್ ಆಗ್ತಿದೆ ಸರ್.
Okay, because of some network issues. Okay, don't worry. Again, you do this next class. Again, we go for this topic. Okay, switching software, switching system software. Again, we are discussed. Okay, no issues. Okay, today we'll stop here. We'll continue in the next class. Thank you.
Okay, sir. Thank you, sir.
Thank you, sir.